All right, problem 1 in section 2.8 asks you to use the intermediate value theorem to show that this function right here, f of x is equal to x cubed plus x, takes on the value 9 for some x value in this interval right here. So they were very specific here in telling us where to look. So when we set up the intermediate value theorem, usually the first thing we would do is make an equation and then get everything on one side right here to be a function, but they've already done that for us. F of x is defined right here. So our job then is going to be to skip directly to the table, f of x here, and they're already telling us what values to use, a 1 and a 2. So let's take a look at what happens when we evaluate f of 1. 1 cubed is 1, plus 1 is going to get us a y value there of 2. Now when we put in a 2, 2 cubed is 8, plus another 2 is going to get us to 10. Now, if anybody did this problem and got confused and surprised, because usually what we expect to see here is a sign change between those two numbers, that's because the value that we are normally looking for right here is usually 0. And you can't jump from a negative to a positive number without equaling 0. Well, in this case, they want us to show that this function right here has to equal 9. Well, what I'm hoping you noticed right here, we started off with a y value less than 9, and we ended with a y value greater than 9. So because f of x is a polynomial function, it's continuous for all real numbers, including on the interval from 1 to 2. So this continuous function cannot jump from a y value of 2 to a y value of 10 without hitting a y value of 9, where somewhere in between this interval here from 1 to 2. So that's really all the work that you would need to show here, guys. If we can really just show that f of 1 is less than 9 and that f of 2 is greater than 9, then we can conclude that f of c has to equal 9 for some c value in the interval between 1 and 2. So that is really all they wanted you to show on this problem right over here. So because we started less than 9 and ended greater than 9, we've got to equal 9 somewhere in between.